Sorry guys, we were on mute. So welcome to join this webinar session. My name is Haimo Liu. I'm the product manager for NiFi and also flow management, part of Hortonworks DataFlow. So personally, I've been with Hortonworks since December 2015. It's very honored to be part of the NiFi team, work with all the engineers in the past couple of months. So today with me, we also have Brian Bandy from the NiFi engineering team, who is the engineering lead driving HDF platform definition, and also a platform integration with other big data products. Maybe we're having some technical issues. I'll try to dial back in.
Okay, I think we got our sound issues worked out. As Haimo said, I'm Brian Bandy, a software engineer working on Hortonworks DataFlow, specifically working on a lot of the integrations between NiFi and the other projects in the ecosystem. I've been with Hortonworks for a little over a year, and I'm also a PMC member on the Apache NiFi project. So I'll turn it back to Haimo.
All right, thanks, Brian. Let's get started. So Hortonworks DataFlow and HDF is part of a complete data connection system, right? So think of data in motion plus data at rest. So in the modern data architecture, people are very likely looking at some kind of a hybrid infrastructure. There could be a on-premise part of it, and there could be a cloud part of it. So HDF and HDP putting together, they can provide this end-to-end solution in order to move anything, move any data from anywhere to whatever your preferred data lake. So they offer this end-to-end solution in terms of turning your data into either historical insights or some perishable insights, depending on your business needs. So both platforms support a number of Apache open source projects, but with a different focus. So I wanted to zoom into the HDF part of the platform and look at what Apache projects are involved and part of HDF. So previously in HDF 1.x release, HDF was perceived as kind of equivalent to Apache NiFi, but that's starting to change from HDF 2.0. So this is our product offering of HDF 2.0. From a stream processing perspective, we have Apache Storm that handles complex event processing. We have Apache Kafka for data buffering and also data distribution. From a flow management perspective, we have Apache NiFi that lives in data center, and also Apache MiNiFi that's running on the edge. From an enterprise kind of foundational service perspective, we have, like all these other components, we have Apache Ranger that takes care of a centralized authorization management, and also Apache Ambari for cluster management, cluster installation, and deployment. We also have Apache NiFi in there that provides a secured communication across multiple data centers. So now if you double click on this chart, you are going to see this is our end-to-end solution for stream processing plus flow management. And this is a holistic view of HDF as a platform, moving data from all the way from the left and to the right, and also pushing commands and context from right to left. So on the edge, right on the far left, you are typically facing some challenges of a bandwidth limitation, of a power limitation, etc. So essentially, you just don't have enough control of your environments, not as much as you could have inside a data center. So Apache MiNiFi is a sub-project of Apache NiFi, which was designed to specifically solve that first mile data collection challenge. In the middle, you can see there's a bunch of NiFi boxes, and you can envision for those NiFi instances to be running like in branch offices or in regional centers, doing some kind of a simple event transformations or calculations before you send data back to data center. Now on the far right, within data center, you have NiFi again, and these NiFi instances are mostly running in cluster mode, right? A typical throughput we have seen from a single NiFi node is around 50 megabytes per second. So in your data center, if you have a massive amount of data to deal with, for example, it could be like 500 or 500 megabytes per second, you can stand up a 10-node NiFi cluster for that kind of throughput. And in addition to NiFi, within data center, you can do all kinds of complex processing by leveraging Apache Storm, right? And within data center, that's our tier 3 flow management, plus a centralized processing power. So think of HDF providing this tiered approach for flow management plus the stream processing all together as a single platform and single product offering. So moving forward, let's zoom into the flow management part of the platform, which is powered by both Apache NiFi and Apache MiNiFi, which is the sub-project. So there seems to be some consensus in the market that big data's biggest problem is, how do I get my data in my data lake? Even for the best data scientists, they still have to spend a lot of time to do the plumbing work before they can really be creative and use their brain power to turn data into insights. So you probably want to leverage some kind of products, out-of-the-box products, to do the plumbing work for you, so that your data scientists can really focus on their real job and working on the data. So here's a quote from one of our HDF customers. HDF helps us to streamline the flow of data and build models and visualizations very quickly, so that my team can work iteratively with the business colleagues on building solutions that work for the business. So that's very much matching with our vision for HDF. So Hortonworks DataFlow makes life easier to move data into Hadoop or any other places where that data is needed. So the flow management part of HDF provides like a real-time interactive visual control of your data flows. And we call it data logistics, right? Think of FedEx or UPS for data transport or logistics of data, right? HDF is that UPS or FedEx for delivering your data from hundreds of thousands of sources and back to your target systems. So HDF can really accelerate ROI of your big data by removing any manual labor or manual cost of data collection and data transport. So coding is no longer necessary in order to manage your data flow in that space. So before I jump into the new features that are introduced in HDF 2.0, just for those of you who's new to NiFi and HDF overall, I just wanted to give you a very quick click-through demo of how you can start up a data flow in NiFi, just to kind of bring you up to speed about the NiFi terminologies and NiFi concepts. So building a data flow starts from kind of a dragging and dropping a source processor on your flow canvas. It could be like a processor to collect the data from HDFS or from MySQL database or from a particular HTTP endpoint, basically anything. Now without NiFi, you can still write a script to talk with HDFS asking for that data or talk to a web server asking for that HTTP data. Well, you have to essentially be able to speak all those different languages, so-called protocols, right? Now, when you talk to HDFS versus a web server, you have to speak a different language. Now, think of NiFi as a translator, right? You speak to NiFi in this kind of visual language, and just by dropping different things on the canvas and connecting different things in whatever way you like. It's actually pretty fun to speak that language. And behind the scenes, NiFi is going to translate all those visual actions into different languages that HDFS or a web server can both understand. So the whole process is transparent to end users, and that's the best part of Apache NiFi. So in HDF 2.0, we have 170 plus processors, and the community is growing really fast. In every HDF release, like every 12 weeks, we're seeing tons of new processors. So in my past life, I came from a company whose major product was a proprietary platform. I was actually impressed by how much an open source project can grow in such a short time frame between now and when I would join Hortonworks. So in this case, going back to the data flow, I'm going to pick a Twitter processor that talks to a Twitter streaming API in order to get some tweets in real time. So, and I can kind of further configure that processor to specify in terms of a particular search keyword, so my Twitter account tokens, and the frequency of getting the streams of tweets. Now my Twitter processor can collect the data from the Twitter API, and I need a second processor in order to ingest that data stream into some kind of a downstream application. So I'm looking for a put type of processor right here. I'm going to use a put file processor in order to ingest the tweets into my local file system just on my laptop to make it simple. And I can kind of simply connect the two processors and make them work together as the end-to-end data flow. I can further configure that connection between the two processors in order to define some priorities of handling the data that is being queued at the connection. And I can kind of click the start button to trigger my data flow. Once the data flow is started, you don't have to stop the whole flow in order to reconfigure a component. So for example, in this case, if I just wanted to ingest the incoming tweets to a different folder on my laptop, I can just stop and reconfigure the put file processor without turning off the get Twitter processor. Well, that way, my incoming tweets are still being buffered at the connection. Now, once I restart that new, like a reconfigured put file processor, the flow continues to operate. Now, the point here being, think of a water system metaphor, right? I don't have to shut down the entire water system in order to fix some pipes. I have some built-in buffering mechanism within NiFi. All right, so that was a very quick introduction to HDF and NiFi in general. If you wanted to go deeper and learn more things about NiFi, definitely feel free to check out the very first session in this webinar series. Now I'm going to kind of switch gear and talk about the new features that are introduced in HDF 2.0 specifically. Data flow challenges can come from a few areas. I wanted to frame this conversation in a way that allows me to walk through how HDF 2.0 can help in these areas. So challenge number one, having to deal with different devices and different protocols and different ingestion and delivery mechanisms. It's very challenging in that area. And number two, oftentimes data flow challenge also comes from a globally distributed organization, right? People have to take disconnected networks into consideration. Also, another challenge comes from the fact of the lack of intelligence on the edge. And in addition to all that, people really worry about time to delivery. In order to add any new data source or any logic to handle data flows, think of a transformation from an upstream process to a downstream process. For a new transformation mechanism, it is not acceptable to wait for weeks or months. It's definitely preferred to do that like in days or even hours. So these are the kind of major challenges in the flow area. Let's kind of double click on every one of these and get a little bit deeper. For every challenge, I wanted to cover NiFi's capabilities before and after HDF 2.0 release. So the first challenge comes from having to deal with different devices, right? So typically, you have many different standards, different protocols, and different formats to consider. As an example, my device supplier might have upgraded their devices a couple of times in the past 6 months. So from an end user perspective, I cannot simply retire my first generation device because I paid a lot of money for that. But in the meantime, I've also purchased the second and third generations. Now in the end, I have to be able to collect data from all those different devices, different versions with the different formats and different protocols. I have to support even legacy standards. It's really painful process to talk to all these different devices. So NiFi can solve the problem by introducing a number of processors out of the box that handle many different formats, protocols, and data sources, and the whole process is transparent for end users. NiFi offers a very intuitive UI. It's not a developer-facing product, but an end-user-facing product. So any operational people, they can come into NiFi and they can open the NiFi UI. They can build a data flow ingestion pipeline without having to code. For those data sources and protocols that we do not support today, NiFi has a very extensible framework, allowing users to build a custom processor in hours or even days to just support a new data source or new protocol. It's very easy to do that in NiFi. So in HDF 2.0, we have further expanded the ecosystem integration coverage. Now we have 170 plus processors available in total in HDF 2.0, right? So HDF 2.0, in fact, has 30% more processors than the previous HDF 1.2 release. Some examples, there's a new Slack processor, there's a new a DynamoDB processor, and for those of you who are interested in the IoT space, MQTT protocol is a big deal. And definitely that goes well with our MiNiFi story in order to handle things on the edge. Think of IoT use cases, right? Apache NiFi is, on the other side, is one of the very well documented Apache projects. If you look for more detailed explanation of these processors, you can definitely check them out online in Apache land, or just reach out to Hortonworks via Hortonworks Community Connection. It's a really great resource, I believe. So here's a quick summary of the major kind of new processors that are introduced in HDF 2.0. For example, there's a Kafka bundle. Previously, we had a put Kafka and get Kafka processors. They were both using Kafka 08 client libraries, and they worked against the Kafka broker version 08. Starting from HDF 2.0, we are introducing the new Kafka processors, which can work against both a Kafka broker 09 and Kafka broker 010. And also we support Kerberized brokers, as well as a communication actually a secured communication between Kafka client and Kafka broker, which is secured by SSL. That's the Kafka side of the house. And also we have a new JSON to JSON transformation processor. So this processor allows users to manipulate JSON data on the fly. Well, the idea is for users to provide a JOLT spec. It stands for JOLT. It's a JSON to JSON transformation library in Java. So that JOLT spec will be embedded into a NiFi processor, and it could be executed against an incoming JSON flow file and produce an output JSON flow file. Different specs can map to different JSON transformations. On top of it, we also provide a custom UI just for this processor in order to display a preview of expected output JSON data for any given JSON input. It's a very powerful processor for people to kind of work with the JSON data. We also have a generate table fetch processor. A lot of users are looking for a scoop-like interactions with the database tables in NiFi. So this is a really enhanced version of the query database table processor. So that query database table processor can do incremental fetch, but on top of that, the generate table fetch processor also offers a capability to do a distributed fetch. You can specify how would you like to partition the source database table and then allow multiple NiFi nodes to pull against different table partitions. We also have a bunch of new Hive processors, so these came out very often in Hadoop use cases. Hive is a very popular component in Hadoop, even in CDC conversations. So some users are trying to capture the updated records from RDBMS and deliver those records to a Hive table in order to keep the two tables in sync between Hive and HDF and RDBMS. And we also have two new processors to interact with MQTT broker, as I talked about before. You can deliver data to an MQTT broker or get data from that broker. MQTT is a very IoT-friendly protocol. So that's on the processor side of the house. NiFi has a very intuitive UI. People get it, they love it. But even that UI for us, it feels old. It's been out for a long time, for many years. So definitely time for us to bring that user experience to the next level in HDF 2.0, making the whole UI easier to operate with the different roles and different authorization policies. So this screenshot shows the new look and feel of the UI. I'm not going to spend too much time here. I'm sure you will like it if you play with NiFi. Just give it some time and just play with the new UI. For those of you who have been using NiFi 0.x release, just to give you guys a heads up, some actions have been regrouped and repositioned on the canvas. So in case you have any feedback about the new experience, doesn't matter if it's a positive experience or negative experience, definitely let us know. We will keep improving the UI. The point here is NiFi team is fully committed to building the best possible user experience ever. So any feedback is more than welcome for the NiFi team. Moving forward, another challenge comes from a globally distributed organization, meaning that you have to consider data flow across multiple data centers. So maybe I have a data center in China, another one in the US, another one in Japan. It's not going to be trivial to move data across all those different geographical boundaries and disconnected networks. So I might have different regulation requirements, right? As an example, maybe GPS data can never leave China. If you want to leverage GPS data to do some processing, you have to do it before you deliver that data back to your core data center. So that's all about pushing intelligence all the way towards the data source, right? As close as possible to the data source. And the whole scenario is definitely NiFi's bread and butter use case, right? So NiFi instances living in different network domains, they can talk to each other via this internal communication mechanism, which is known as a site-to-site protocol, right? So that site-to-site protocol can be secured by two-way SSL. So you don't have to worry about security issues when that data is traveling outside of data center. On top of it, NiFi is a environmental neutral product. You can run NiFi in cloud or on-premise, even between different cloud providers. Given the site-to-site communication protocol, you don't have to worry about data transport even between like AWS and Azure. NiFi is a vendor-neutral product. Right, so what's new in HDF 2.0 in this area? We are enabling a variable registry to specifically solve the challenges considering a distributed organization. So for example, in a lot of use cases where you need to move data across environments, as of today, you can use templates in order to move a data flow from dev to production, and we're trying to further improve that user experience in HDF 2.0 by introducing this variable registry. So why we do that? Because the challenge is you have to update environmental specific values after moving your data flow from dev to QA to staging to production. As an example, connection string, right? It's very likely different in all those different environments. So I don't want to, from end user perspective, I don't want to manually change all those connection string values after moving my template. So what we have done in HDF 2.0 is really a phase 1 implementation of a variable registry. Essentially, that allows users to specify some config files, and you can store like a whole bunch of key value pairs in that config file. You can then have a environmental specific config files in dev, in staging versus in production, which contain all those config files. They contain the same keys, but mapping to different values. Now, when you start a NiFi server, this key value pair or all those key value pairs will be loaded into this in-memory variable registry. So if you reference the same key, for example, quote-unquote, DB connection in your flow template, the value, the real connection string, will be automatically resolved based on different environments. So after you move the flow from dev to production, now when you start your NiFi server, a different connection string will be automatically loaded into the production variable registry. It's very powerful in terms of helping the flow provisioning, right, across different environments. Another area of improvement is a better deployment management for NiFi, right? Essentially, how you can simply stand up a NiFi service or NiFi instance in a big data environment by leveraging Apache Ambari in HDF 2.0. So Ambari is one of the things we heard from many HDF users and especially HTTP users. They're looking for a strong integration with Ambari. Point here being a nicer user experience for deployment and also for cluster management. In HDF 2.0, user can leverage Ambari for NiFi cluster management, which includes like a deployment of a NiFi instance, starting and stopping a NiFi service, or providing the centralized place for configuration management. Ambari also provides a very nice built-in monitoring functionality, and Ambari can manage Kerberos authentication for NiFi. So having said that, you will have like all those different deployment options in HDF 2.0. I believe Ali Bajwa from Hortonworks, he has provided another webinar with a focus purely on NiFi Ambari integration, so with more details. So definitely feel free to check out that webinar if you are interested in everything like NiFi Ambari related. I don't want to spend too much time here to repeat that thing, but the important message is you will have many more different deployment models or deployment options than what you had before in the previous HDF releases. Now in HDF 2.0, we are making the site-to-site communication more plausible, right? Make it more friendly to different protocols. In HDF 1.2, the default site-to-site protocol was a TCP protocol, while in reality, depending on your data architecture, some people might prefer an MQTT protocol, right? I'm running NiFi on the edge, or some people, they prefer HTTP protocol. So we just wanted to make the site-to-site communication more plausible, allowing users to add a support to any protocols if they like. And on top of it, we can also, we also wanted to add a support to a proxy server. For those users who do not want to punch holes on their firewalls in different data centers, just to enable NiFi communications across multiple data centers. They can do it in HDF 2.0 by embedding a HTTP proxy server into the site-to-site communication. That's a new feature in HDF 2.0. Keep going there. Another challenge in this area is, in the data flow area, is edge intelligence, right? Speaking of edge devices, you have to consider things like unreliable network conditions. For example, Wi-Fi is cheaper, but you do not always have Wi-Fi as an option. Well, LTE is more reliable, but it is more expensive. So when do I send data over LTE versus when do I send data over Wi-Fi? It's a very reasonable question to ask on the edge. So essentially, we wanted to enable some analytics on the edge before you even send data to data center. As an example, my brake sensor data is typically lower priority data. So I definitely just wanted to send that data via Wi-Fi, right? But if there's abnormal patterns being detected, that indicates my brakes are having some issues. So starting from that point, I wanted to start pushing my brake sensor data via LTE. So I wanted to make that kind of intelligent decisions on the edge, right? It'll be too late after I see that data in data center. Additionally, a site-to-site communication enables this bidirectional communications. You can send data from left to right, and you can send commands or context from right to left to the edge in order to adjust flow behavior on the edge. Moving forward, in HDF 2.0, we are officially introducing the edge data collection agent model, known as Apache MiNiFi, which is a sub-project of Apache NiFi, specifically designed to solve data collection challenges on the edge, and also the bidirectional communication. It is particularly designed to solve the difficulties of managing and transmitting data feeds from the source of origin and back to data center in order to enable intelligence, in order to adjust kind of data flow behavior with the bidirectional communication. So, and it is designed to specifically solve the first mile data collection challenge. The MiNiFi has a very small and lightweight footprint, and MiNiFi can generate the same level of data provenance as you can do in NiFi, which is a very important message to enable edge analytics and IoT use cases. On the other side of the house, MiNiFi is also a little different from NiFi because it is not a real-time command and control interface. In fact, a MiNiFi agent doesn't really have an UI at all. And because MiNiFi is mainly designed for design and deploy kind of situations, meaning that you can design data flow in NiFi, and then you can deploy that data flow to your MiNiFi agent on the edge. You don't have to open the UI of a single MiNiFi agent, go in there, make modifications, and repeat that effort for every single MiNiFi agent. It'll be a lot of overhead, right? So that's why we wanted to go for a design deploy pattern. MiNiFi also enables a warm deployment of data flow, meaning that you don't have to manually shut down the agent in order to update your data flow on the MiNiFi agent. The changes, the flow deltas, will be automatically picked up by the MiNiFi agent from a YAML config file. In HDF 2.0, we have a GA release of a MiNiFi Java agent and a tech preview release of a C++ agent, whose footprint is even smaller than the Java agent. While in general, both the Java MiNiFi agent and C++ MiNiFi agent, they all have a refactored framework, which is optimized for smaller devices. And MiNiFi doesn't really carry as many processors as NiFi has by default, but you can always plug in the processor to a MiNiFi agent if necessary, depending on the use cases. So we give you that flexibility. So keep going here. Another area in the data flow, another challenge in the data flow area is we got a lot of questions about the difference between something like Apache Camel and Apache NiFi. So NiFi is a flow management application. It's not a framework, right, such as Camel, or a ingestion framework such as Flume. You can do a lot of things in Apache Camel or in Apache Flume if you are a programmer. Well, on the other side of the house, NiFi provides like a lot of out-of-the-box functions in the data flow space. Right? Any operational people, they can manage data flow in a very user-friendly manner. You don't have to go through the whole data flow development cycle in order to make a simple flow change. And because of that, you can dramatically reduce time to delivery in terms of building a data ingestion pipeline, right? Instead of leveraging a framework, you can use a application, right, such as NiFi. Now, a couple of NiFi's key capabilities in this area. Number one is traceability, right? Data provenance, out-of-the-box data provenance that helps you understand data coming from different data sources. You no longer have to manually join different data logs in order to figure out what happened in the past. You can look at the provenance data and data lineage information from within the NiFi UI. And also there's a visibility part of it. NiFi offers a big picture of your enterprise level data flow to business users. You don't have to guess how the flow looks like in your mind. You can see all that on the canvas with the UI, right? Another part of it is failure handling. If you think of failure handling, NiFi really allows users to define what success or failure means to you at every point of your flow, and how would you like to handle those failures. I can either kind of reprocess a failure after certain times, or I can directly route a failure to a different place, right? It's very flexible failure handling, which is offered out of the box. In things like Apache Camel, you have to go to every single connection and code how would you like to handle failure. It's a very time-consuming process comparing to NiFi. So in HDF 2.0, in order to further enhance the application framework, we are adding support to zero master clustering, right? Think of a control plane high availability of the application from a cluster management perspective. So the master process NCM in HDF 1.2 or NiFi 0.x release, that NCM was a single point of failure. So when your node running NCM is lost, your data flow continues to operate, but you cannot view your data flow or make any change in real time. Now, starting from HDF 2.0, we have eliminated that single point of failure by introducing a new clustering paradigm. You can have effectively multiple entry points, and there is no more a master process. So one of the NiFi nodes will be automatically elected as a cluster coordinator, and the failover of that cluster coordinator will be handled by the framework automatically, without any manual effort involved. Now, with that being said, the control plane is going to have a much higher availability than it was before. So all the NiFi nodes that are involved in the NiFi cluster, they are able to execute data flow functions. So previously, one of those NiFi nodes has to be elected as a master process, which was called a NCM. It was confusing for end users because how do I configure how much more resource should I assign to that master process or to that node running master process? Now in HDF 2.0, all the nodes are equivalent. It's much easier for you to set up a NiFi cluster from an admin perspective. Technically, we use Zookeeper to facilitate cluster management, which was the best option we can find technically. In the meantime, we also made the cluster management pluggable. If any new technology happens to come out and turns out to be better than Zookeeper, we can easily switch to the other technology. We're not really tied to Zookeeper from architecture perspective. In HDF 2.0, for cluster management, you can configure either a Zookeeper, like either a internal Zookeeper or an external Zookeeper quorum, right? By internal Zookeeper, I mean you can embed some Zookeeper nodes on the NiFi nodes, or you can just run an external Zookeeper that manages a NiFi cluster. You have that flexibility. So right here, this is basically how zero master clustering works. One of the NiFi nodes will be elected as a cluster coordinator, which is handled and selected by Zookeeper. Assuming in this case, node number 2 is the cluster coordinator. So every other NiFi node will be reporting to this guy with heartbeat messages every 5 seconds, which is a configurable time interval. So once I receive a REST API request from a client, right, from a web server, from a web browser, it'll be routed to the cluster coordinator first. And that cluster coordinator will broadcast that information to every other NiFi node to collect the response from all those nodes and then expose a centralized response back to the client, back to the browser. So from end user perspective, I can effectively send API requests to any NiFi node, and therefore I have multiple entry points, right? I can type the URL of any node in my browser in order to access the same NiFi cluster. So effectively, any NiFi node can understand the status of all the other NiFi nodes within the same cluster. Now, status here being connectivity information, which node is connected, which node is disconnected, which one is connecting, which one is disconnecting, that kind of thing. They also understand the workload information of every single NiFi node, meaning the amount of data being queued or the amount of data being processed. They also share identifier information, right? Host name and port number, that kind of thing. So effectively, every node understands every other node in NiFi cluster. Another kind of important concept here is about a primary node. In systems like Kafka, you push data to Kafka and then you pull data from Kafka. In systems like NiFi, when you get data, you get data into NiFi and you get data out of NiFi, and we support both pushing and pulling mechanisms, right? It's not really a single mechanism for, getting data into NiFi or getting data out of NiFi. It could be bidirectional. So to achieve that, think about it in a clustering manner, where you need to kind of go out and pull data from external systems. Sometimes you don't want to have all the NiFi nodes hitting that external service all the time, which is why we introduced this primary node, allowing one particular NiFi node to interact with external service. You don't have to do it, but that's an option, right? Primary node. So taking that into consideration, in the cluster design, right, there is one cluster coordinator and there is one primary node. They could be running on the same physical machine or they could be running on different physical nodes. It's a separate logic to handle the failover of a primary node and then the failover of a cluster coordinator, right? If your cluster coordinator is lost, that triggers re-election of a cluster coordinator, but not the primary node. They don't have impact on each other's logic in terms of failover handling. In HDF 2.0, we are also adding support to a multi-tenancy feature, which includes a multi-tenancy kind of flow editing capability, as well as a multi-tenant authorization. Those are two different things. So essentially, we allow different teams working on the same canvas in a multi-tenancy manner. So with that access control, your flow is protected against any unauthorized users or unauthorized usage at the component level, at processor level, which is a permission control at a very granular level. In the previous releases, for example, in HDF 1.2, if you and I are modifying different processors on the same canvas, whoever clicks the apply button first, that person can save the change, while the other person will get an error message because that canvas is being modified by somebody else. It's a very frustrating situation. Now, what we hear from a lot of HDF users is they look for some kind of a self-service model for data flow management. So they envision to have multiple teams accessing the data flow on the same canvas, and they can all make changes at the same time. So in HDF 2.0, we are offering this collaborative model in a multi-tenancy manner. So think of a Google Doc. It's a very, very similar experience. So everyone can effectively work together on the same canvas, but at different components or different processors. You can interactively control your components or your processor, and when you edit that processor, only that single processor is being locked, not the entire flow on the canvas. So I can effectively modify my processor in the meantime while somebody else is making a different change. And another big muscle movement feature is known as a multi-tenant authorization, right? So in HDF 1.2, we had a kind of role-based authorization. Now, in terms of roles, think of read-only users, data flow managers, or admin users. They either have some kind of a privileges to the entire canvas, or they do not have that permission, again, to the entire canvas. There was no processor-level authorization control. Now, what we offer in HDF 2.0 is a component-level or processor-level authorization based on this new authorizer API, right? Effectively, you have two different types of permissions. There is a read permission and there is a write permission to every single NiFi processor. Now, the key is we wanted to offer protection against any unauthorized usage without losing context. If you look at any other systems who offer this kind of multi-tenant authorizations today, think of a topology-oriented streaming system, right? They all have some kind of isolated topologies, while the reality is these components, these topologies, they're not 100% or completely isolated. They're just the different parts of the same workflow. By isolating those topologies, you lose context. So your business units are protected, but from end user perspective, they don't have a clue of how things work together or how different units are connected. Now, what we are trying to do here is to make it all visible so that you can see you are part of a larger tree while you are still offered with the capability to protect against, to protect yourself against unauthorized users. So this is definitely one of the key differentiations that we are going after in HDF. So from a policy management perspective, we offer two different options in HDF 2.0. Option number one, you can open NiFi UI, and then you can manage users and policies and permissions within NiFi as an application. Option number two, you can also leverage an external service to manage users and policies for NiFi. As part of the HDF 2.0 stack, we enabled Apache Ranger to manage policies for NiFi as an option. So you can go to Ranger and you can define those permissions for every single NiFi processor. And Ranger can provide a centralized place to manage policies across even multiple applications. Think of, NiFi and Storm and Kafka, all managed, or authorizations for those components, all managed by Apache Ranger. So this screenshot here shows a user interaction with the processor, assuming that user has a read permission, right? So from that user perspective, I can see the name of the processor. I can see, for example, the statistics of the processor. If I right-click that processor, I can also see all the configurations, all the properties of the processor. And on the other side of the house, as another user who doesn't have the read permission, I cannot even see the processor name. I cannot even guess, what that processor does. It looks like a black box to me. If I right-click that processor, I cannot see properties or configurations. I cannot see any details about that processor except for statistics, right? Those numbers are still exposed to that user on the face of the processor in order for that user to be aware of the context, right? So that essentially enables that user to design a data flow with the full awareness of the global context. As an example, knowing how much data being queued and how much data being processed by an upstream processor, it'll be very beneficial for me when I, for example, design an downstream processor or application. I can set up like a back pressure properly from that perspective, just knowing the context. So again, for any kind of further questions, definitely check out Hortonworks Community Connection, or known as HCC. So every morning when I wake up, the first couple of emails I got are typically kind of notifications from HCC that tells me, Brian Bandy just answered all these like 5 or 10 questions. Please come over and check it out. So people there, I promise you, are very kind of responsive. So now I'll give it to Brian Bandy to kind of answer some questions popping up from the chat room while I was talking. You can have that kind of real-time HCC experience.
Sure. And just in case we don't get to any questions, we do plan to provide answers to all questions afterwards, but we'll get to what we can. So earlier on, there was a question. When we click Start on a processor, I understand processing will be continuous, but how often, for example, will the Twitter API be pulled for messages? So every processor has a concept of how it's being scheduled. When you right-click on a processor, one of the tabs on the configuration is the scheduling, and there's basically two main ways that processors are scheduled. There's timer-driven and cron-driven. Timer-driven is the default scheduling strategy. You're basically telling it run on some time period, right? So the default is 0 seconds, which actually means run as fast as possible. But a lot of times for your source processors, you're not really trying to hit external system as fast as possible. You typically want to pull it on some interval, so you might set that to run once a minute or run every 5 minutes. And you can also make use of the cron scheduling if you want to use your standard cron expressions to run at specific points in time. So generally it comes down to how that processor is configured to be scheduled. Next up, using HDF, can we do analytics on data in motion, or does it have to get into Hadoop for doing analytics? So absolutely, you can do analytics on data in motion. If you remember what Haimo described, how HDF is made up of several different technologies, a couple of those being NiFi, Kafka, and Storm. A very common use case you'd see is using NiFi to get data from wherever it is into Kafka, and then using Storm to read that data from Kafka, do your stream processing analytics there. From there, you can really do whatever you want with the results. One approach might be write those results back to another Kafka topic, have NiFi listen for those results, and then send those results somewhere. So doing analytics on data in motion is absolutely a major use case for HDF. Obviously, another use case is using those technologies to get data into Hadoop as well, or maybe doing both at the same time. Next up, have the HDF 2.0 UI changes provided a way to create separate data flows in order for different teams to use HDF and NiFi without seeing each other's processors? In other words, does it provide better multi-tenancy for larger enterprises? I think Haimo touched a lot on this, but just to make sure it was clear, that's definitely one of the focuses in HDF 2.0 is multi-tenancy. It doesn't come down to completely separate worksheets that you see in terms of the canvas, but the permission model that Haimo described essentially gives you that, right? So the process groups in NiFi, you can give each process group a different set of permissions, so one team cannot go into another process group and see what a different team is doing there. And all the permissions are in a hierarchy, so if you apply those permissions at your top level process groups, you can isolate different teams within the canvas. Another question about how can I route API requests to a cluster when a coordinator or any client could go online or offline at any time? I understand the cluster will stay up, but how do I get my API requests routed? Is this also part of what primary node would be used for? So there could be, I guess, two different scenarios that we're talking about here. One of them could be more about I have a NiFi cluster and I have some processors listening for data, and how can I have the system that's sending the data send that data to all the nodes and make sure it's sending to the nodes that are up. Typically, one example might be a listen HTTP processor. So in that case, what you'd probably do is put a load balancer in front of NiFi that was pointing to each one of those listen HTTP processors, and the sending system would send data to the load balancer, and it would handle the round robin and knowing which nodes are up. If you're talking more about the NiFi API, I suppose you could do something similar with the load balancer, but if you're just doing something like scripting API calls to interact with the NiFi API, you'd probably just handle that in the script yourself. You'd have what are the URLs of your cluster nodes, and you'd have some mechanism for saying, if this request failed, let me try another node, right? Moving on to another one. Is there any requirement to use Ambari if we want to use Ranger for security, or are they totally disconnected? There's not a requirement, right? NiFi has the ability to choose what authorizer to use. You can either choose NiFi's internal authorizer or the Ranger one. And Ranger is obviously a project that is an Apache project on its own and is not tied to Ambari. So you could run Apache NiFi with the Ranger authorizer talking to Apache Ranger. Ambari gives you a very nice way to manage those two technologies together. It helps you configure them. It helps with a lot of the security aspects to create secure connections between them, and removes a lot of the manual steps that you would have to do. I'm just seeing what other questions we have here. Can we use HTTP Ambari to manage HDF? Currently, right now, it's two different Ambari instances. So you'd have your Ambari instance where HTTP is installed, and you would set up a second Ambari instance where you would install the HDF stack, which would give you, NiFi, Kafka Storm, any of those other components, Ranger, if you want to install it. So currently, the approach is there's two different Ambari instances right now. Let's see. Can you provide an example of how the per processor authorization is expected to be used? Apart from processors, what else can be authorized? So essentially, everything in NiFi can really be authorized. So process groups, which includes the root canvas, which is the root process group, and then any sub-process groups, processors, controller services reporting tasks, pretty much any action, even things like who can create policies and who can add users and who can do all those types of administrative actions. All those things are controlled by a policy. So you could have, for example, one user who may not be able to, they may be able to change anything on the canvas, but they might not be someone who has admin privileges to go in and modify the policies and users and groups, right? In terms of per processor authorization, there may just be one processor that needs to be restricted to a smaller set of people. So maybe that one processor has a specific policy on it that says only these 2 or 3 people can, see the configuration of this processor and change it. So maybe there's sensitive information in the configuration, I don't know, URLs or passwords or something that you don't want them to see. You can completely lock down that processor so that no one except these couple of people can see it.
Yeah, is this being recorded? Yes, the whole session is recorded. We're definitely going to share the webinar right after the session here. And another question is about kind of NiFi versus Storm. So NiFi really is not another kind of processing framework, right? You don't want to use NiFi to do heavy lifting processing, but rather use NiFi to feed data into things like a Storm. So we like to think about NiFi versus something like a Storm is whether that processing is a simple event processing or that's a complex event processing, right? From a simple event processing perspective, usually we're able to operate on a single piece of data. By that data itself, we're joining with some kind of enrichment data set. So things like enrichment or data transformation, those are definitely the bread and butter use case for NiFi from a processing perspective. Now, if you think about complex event processing, we are typically referring to processing data from kind of multiple data streams together, like think of a joint operation, right? We're analyzing data across a time window. So think of kind of calculating a standard deviation, right, over the last 30 minutes. The difference here being the complex processing, we're getting some kind of a insight from operating against multiple data streams. And in terms of a simple event processing, we're really just trying to transform or enrich that individual piece of data, right? So that's, from my view, that's a big difference between something like a NiFi and something like a Storm. All right, I think we're probably running out of time, so that'll be all the questions we answered today. For anything that's not addressed, we're definitely going to publish a blog to cover all those questions. All right, thanks for jumping on the session.